A truck of mass 8 metric tons. Okay, so this is in metric ton. Moving up an incline of 3 in 1. Okay, actually, let's start drawing. Then only it makes sense. Metric ton moving with inclined plane. Okay, so I'll directly do it. Let's draw a big fat diagram and be done with it. So we have the gravity. Oh, this is too big actually. Maybe this will help. Huh. Better. So we have gravity. Gravity is pulling down 80,000. No, 8,000. 1 ton is 1,000 times of 10 Newton. I'll start writing this way. This makes sense. Then I'll not make a mistake of taking mass as 8,000, Then if not, I'll take it as 80. And then we have the slope. Oh, for slope, we needed a different place actually. Anyways, you guys can draw a different diagram, a small diagram along with this so that you can mention slope. So if this is 3x, if I happen to, no, wait, if I happen to go up by 3x, horizontally I have to cover 5x. That's the slope. Speed is given. So speed is 12 kilometers per hour. 5 by 18. That's pretty slow. 12 into 5 by 18. 10 by 3 meter per second. Meter per second, speed upwards, and what else? Calculate the power of the engine if the coefficient of friction is 0.15. Yeah, no unit, right? Kinetic friction, this is. What else, guys? So then, of course, there is friction, opposite direction of the motion. And there is, what else? Okay, a truck of mass, calculate the power of the engine. Okay, there's a force that is pulling it up. So we are moving with constant acceleration, is it? A truck of mass moving up an incline at a speed of, yeah, constant velocity, so zero acceleration. So we have to figure out this force basically. For that, of course, we need to resolve this. So this is along the slope and this is perpendicular to the slope. And this is theta that we need to figure out. This is theta. And this would be your normal. Yeah, two diagrams would have helped. We have first thing is let's figure out theta. Finding Nemo. So tan theta is equal to 3 by 5. And so sine theta will be, we can figure out this way. Oh, 3, oh no, 3 and 5, that is not in Pythagorean triplets. So we have tan inverse of, again guys, I'm doing calculator based calculation. If not for calculator, then things will be a bit different. Approximately 31 degree, guys. Then we have sine theta. Therefore, sine theta is equal to, and cos theta is equal to. So cos theta will be 0.86 and sine theta will be 0.52. So with all of this, I can figure out this set of values. And this is 80,000. The normal force will be. So from figure, we have N to be 80,000 into sine of, this is almost half of it, but let me do it. Anyways, I'm using calculator, right? Let's not approximate it. So this is 0.52 and this value turns out to be 41,600 Newton. That's your normal force. And then you have your one along the slope. So that would be your gravitational pull down the sine theta into 80,000, this value. Down the slope, the sine theta gravitational pull would be 0.52. Wait, no, this is cos. Did I use the wrong thing? Wrong, guys. This is 8.6. Sorry, 0.86. And this value is over here. Right? And this value would be 80 into 0.86. 68 and 80,000 Newton. That's your normal force. So we pretty much have all the things. All we have to do is apply. If you want to figure out this too, you can write the formula and figure it out. This is a systematic way to do it. 0.15 into the normal force, that is 68800. So this would be 0.15 into 68800 would be 10,320 Newton. Okay. Now applying Newton's second law along the slope. So what we have here is force will be pulling things up, but frictional force is pulling down, and also your gravitational gravity along the slope. All of this will be equal to 0 as, I don't know what is this. Object is moving at constant velocity. Object is at constant velocity. Okay, so this F is equal to 1300 plus, how much is this, guys? This is 41600. That should be the amount of force. So how much is that? So we have 41600 plus 10230, and we have this to be 51920 Newton. Okay, finally we have the, see, this is your force, right? We need to figure out the power. Power, you guys might not remember this, but power is nothing but rate of doing work, right? And work is force into displacement. So force into displacement will give us what? Sorry, displacement by time will give us what? Velocity. So with this force and with this velocity, I think it's a small velocity. What is the power that the engine is delivering? That is your question. So I just have to multiply 51920 with 10 by 3, and that is around 173.1 kilo would be 3 zeros, right? Kilowatt. So that would be your power in kilowatt.